So what I can do is I can review the entire, well, I can review what we've gone over. So it'll give the viewers a sort of orientation. Yeah, that's a good idea. So I'm going to go ahead and get the STM32 Cube IDE started, and we'll get into it. Thank you, Nazari. Let's see. You have a question. Before I ask it, I just wanted to say that your videos have been very helpful for me, especially in the beginning before I learned to study datasheets, references, notes, etc. Thank you very much. Film. Thank you for coming in. I watched quite a few of your videos. Hey, they are great. Thank you so much, Film. I appreciate that. All right, so we have for anybody new to this space, we program in single bare chip microcontrollers, and this is an STM32. It's an STM32F03, and you can see that we have pretty much just the bare chip, and this is a board that breaks out the bare chip to the pins, and it goes to 3 breadboards, and everything is, there's nothing on this except for the pins, the chip, and there's not even any passives like capacitors or anything. All that stuff you put on, because this is important to understand how circuits are made and what you need to put into a microcontroller circuit. And my aim is to make it easy for anybody to do. That is my ultimate goal, is to try to cover as many ideas or concepts as possible with the STM32 or ARM chips in general. I may be getting into the ESP32 because I have had those requests, but everything is like just bare. It's very minimal. The example I generally give is, okay, so you're a Arduino developer. You've created a lot of circuits. Okay, so that tells me you are interested in microcontrollers. You're interested in electronics. So why not start from the ground up? Imagine you've become an expert at Arduino, and then you say, okay, I want to get a job in this space. I want to go out and become an engineer. In some cases, you could become an engineer without going through college, because of the vast amount of information you can get on the internet and learn and become an expert. But when you get that job and you are, let's say you're going to go work for LG, and you're going to be making washing machines or something like that. You're going to be designing those circuits. You go to your boss, and the boss says, okay, design me this circuit and design me the software, the firmware that's going to be on the circuit. And you start getting to work, and of course, LG is going to want this circuit to be as lean and as efficient as possible. Efficiency when it comes to the way the circuit works, and efficiency when it comes to the cost of the circuit. And then when you get into it, you're gonna you're gonna show all the projects you've done, obviously, to get the job. But when you get started, when you get to work, your boss is going to be only interested in making sure that you're getting this circuit up and going, and the design of the product up and going as fast as possible. So if you are not ready for that, there's going to be some problems. So my tutorials are aimed at the bottom-up approach. It's not for everybody. Some people will never, become an engineer for a company. They may just want to work for themselves and just do Arduino projects and just make all kinds of random things, and that's okay. But if you're looking for the job, and looking for getting into the engineering job, I think this is the way to start. This is my personal opinion. Okay, let me go to the chat. Jabathia, I hope I'm saying your name right. You have done a great work with the STM32 series. I've learned so much from watching your STM32 series. I never dreamed that I could be designing my own PCB and writing C code. Congratulations, and thank you so much. I really appreciate that. Those are very kind words. Nazari, my question is regarding the multiprocessor communication mode of USARTs available in the STM32. I cannot find a lot of its applications on the internet. Have you ever tinkered with it? I have not. Are you talking about the multiple USARTs, or like you have USART 1, USART 2, USART 3, and then using those simultaneously. I can get into that, and I can do experiments with that. And I will be doing USART because I'm going to be, this live stream is intended to do all of those types of experiments. I like experiments. I like to set up circuits and test my own knowledge, or learn from setting up these circuits and learning from chat and learning from the internet and coding and just seeing if things work. And that I think, just like in the last live stream, we had a lot of experiments. I think that's the way that I can make the chat more participatory and it's more interesting. So yeah, I would definitely want to do that. Let's see, MICM Mole. I'm going to call you Mr. Mole. I hope you don't get offended by that. Would you consider doing something on the CAN protocol in regards to communication and data interaction? Absolutely. I will be getting into CAN, the CAN protocol. I want to cover every protocol of all the STM32 microcontrollers. This particular microcontroller doesn't have the CAN protocol, I don't believe. But what I can do is I can get another 64-pin variant of the STM32, and I can look at the CAN protocol for sure. But that'll be way later in the series. But I still invite you to come by and enjoy the experiments that I'm going to be putting in. Nazari, I would, but it's a lot of software overhead that I don't need. My application is a bunch of boards with identical MCUs that need to allow each other's electrical location. Okay, so multi-processor using the same USART. Okay, communication with each other. I did that with the AVR series, microcontroller to microcontroller communication. I will be doing that with the STM32 for sure, because I'll be getting into the wireless stuff like Bluetooth, Wi-Fi, those kind of things. But I'll be getting also into, like, if you have wireless radio like LoRa or stuff like that, and communication with LoRa. I can't remember what protocol they use for LoRa, but I do want to do like connection between two, not even wireless, just direct connection between two microcontrollers and have those communicate. No, there is a mode of USARTs that apparently allows lots of devices on one bus, each having its own address, kind of like I2C, but based on USART. Yeah, and also there's the servos that I have by Dynamixel. They also do the same thing. They have their own IDs, and they use the same USART, and you have to put them on the same line, which is kind of interesting. So you can have like 255 servos, which that's the same as microcontroller. We had that for like a year. Yeah. I drank them all in a span of a year. Okay, sorry about that. Yeah, so I will be getting into that too. So it may maybe I'll be doing that sooner than later, because I have a bunch of Dynamixel servos to play with. So I feel like I should be making some motion here, to keep the video going or something. So yeah, and it's a single line, not a multiple line. It's not like a 2-wire interface. It's a single wire interface. So it is half duplex. So it is you're still reading and writing. You're reading from the Dynamixel servos, which I can't remember what microcontroller they have inside of those servos, but you're definitely doing communication. So I will be getting into that. All right, so I think we have 23 people watching. That's nice. I think that might be my all-time high with the YouTube. So thank you very much for tuning in. And I also want to make sure that I'm watching the Twitch side of things, because I don't usually pay attention to the Twitch side, and I should, but I don't get anybody participating on that side anyway, so I don't watch it as much as I should. But I'm going to put that over here. And all right, so what we've done so far is we have talked about the system clock configuration. This is for the OLED display. So we're going to start talking about the OLED display. The OLED display is it's a little display like this, very small, very hard to read if you put characters on it. And it uses I2C communication protocol. So we've talked about the system clock configuration. We've discussed all of the code within the I2C initialization to make the I2C work. And we got into the OLED initialization and we started looking at the right. So we've looked at the right and we understand what's going on in the right. And if you don't know any of this stuff, I urge you to go look at the previous live streams. There's 2 live streams that are dedicated to this display. And the first one was looking at the I2C initialization. And the second one was looking at the right, the OLED commands, how we get the commands out there, and what the commands mean. We also talked about the data sheet of the OLED display as well, and how to find these commands and what they do, how these commands get to the display and make the display work. And also this was the experimentation portion of the last video. Was we wanted to try to draw our own characters. So we experimented with the character A and drawing that manually. And you can see right here we were looking at the way to do that, and we were successful in doing that. Initially we did it and it looked upside down, and then we had to redefine the code to do it right side up. So we left off looking at what the commands mean, and we stopped around here. So looking at horizontal addressing mode, we tried vertical addressing mode, and we got gibberish here, but we can also look at that again if we want to later on in the series to see what appears on the display. Oh, thank you very much, Resk, for becoming a fledgling engineer. I appreciate that. Let's see. All right, no more new questions. Okay, so there's one thing I was thinking about, and I'm not sure if we're actually reading. We have the write, and do we have a read command here? We don't. So that means that this is only, and by the way, this code is from Claude. I spoke about that in my first video. That's why I'm sort of deciphering this code, is learning through what Claude gave me and making sure that it's correct, you know, as we should, but also learning from it. Nazari says, have you had time to work on the second volume of your STM32 book? I have. It's about, I would say, 1/4 done. I just haven't had much time because of needing to, do orders and making sure Build Your CNC is, still making money for me so I can feed my family. So, but I am going to get to it. I already had enough information for the full volume, but I stopped because of the need to continue working. But it will eventually come out. I apologize for the time it's been taken for that. All right, so continuing on. So let me go back to the commands. So this says set COM output scan direction. So let's see what that means. And I'm going to open up the data sheet that we had before. And the display is the SSD1306, I believe it's called. So here's the data sheet for the display. And this is the command set. So let's see what that next command means. Okay, that's C8. So this, if you look at the, I'll show you it's the SSD1306.pdf. So if you look that up online, you can pretty much find it pretty easily, because that's not the display itself. That's the controller that controls the display. All right, what was that number again? That was C8. And I like to see if we even need some of these commands too. I mean, what does C8 do? Why do we need the command? All right, here we go, right here. C0 and C8. And like I said in the previous video as well, you could, instead of using I2C, you could actually use a form of this that uses this little, see if I can get it closer in. You could just use this cable here, and these have all the data lines, and this set of bits is equivalent to this hex number. And you can see x3 is a variable. It's either 1 or 0. So that's going to be the difference between C8 and C0. So let's see, C0 would be, I'm thinking that would be the C0 would be the one with a 0 at the x3 position, or the D3 position actually. 1 second, I think I lost the video here. 1 second here. Okay. All right. R, thank you for coming in. R. Oh yeah, you're talking to Nazri. All right. Okay. So let's go back to the C0 and C8. I need to turn this thing down or turn it off. Okay. So normal mode is probably what C0 is, and we're using C8. So we're using remapped mode, scan COM N-1 to COM 0. So I'm not really sure what this is doing. N is the multiplex ratio, which is, I guess this could be a different, yeah, this would be it right here probably. So from left to right, remap. So I'm not really sure what this is doing. I probably have to look at it in more detail. So let's try to find it where the explanations are. So that would be COM output scan. This command sets the scan direction of the COM output, allowing layout flexibility in the OLED module design. Additionally, the display will show once the command is issued. For example, if this command is set during normal display, then the graphic display will be vertically flipped immediately. Please refer to table 10-3 for details. That's interesting. So let's go ahead and experiment with that. First, I'm going to display something on the screen. And if there's any suggestions on what I display on the screen, let me know right now. Whatever is going to be on the display will be famous for a little while, or infamous. All right, this is what I put down at the very end of my stream. And if I don't see you, good afternoon, good evening, and good night. So who can tell me what movie that's from? What do you think this is? Actually, I should take it out of the container that it's in. I'm gonna see if I can make it a little bit easier to see. Maybe go a little closer. If nobody has a suggestion on what to put on the display, I'm going to put in something about the... Very good. You got it right. Praven. But what kind of pressure sensor? Okay. Let's put that on the display. I'm going to go ahead and plug in the microcontroller using the STM32 or the ST-Link V2. Vacuum, you're right. Baro. What is Baro? And by the way, if anybody wants to say what country you're from, or where you guys are located, where everyone is located. All right, so I've connected the STM32 to the ST-Link, and let's press the play button. Let's see if it actually does it. Okay, so it doesn't connect to the target because I need to reset it actually. Let me go ahead and reset it. It should have the previous thing that's on it. So let's go ahead and do it again. If it shows up like this, it's okay to program the microcontroller. There's no problems. But if you don't see anything when it's plugged in, then there's going to be a problem. And if you still can't get it to work, then you can always unplug the display and put it, somewhere over here where it's not connected to anything. All right, so let's go ahead and run the program, or flash the microcontroller, I should say. From Ghana, nice. Oh, barometric pressure. No, it is vacuum. Yeah, that's good guesses, everybody. So this actually is a vacuum pressure sensor that goes up to negative 115 kilopascals, which is probably roughly 32 inches of mercury. I use it for my vacuum pressure sensor controller. But this one is interesting. It doesn't have a place to put a tube. So the other ones that I use actually has a cap here and has a tube fitting. So you can take that tube and put it to a vacuum like tank or something like that. But this one is probably intended to be in a vacuum chamber or something like that. So like you'd have the circuit and everything inside of the vacuum chamber. Okay, so we have liftoff, everybody. Starship has launched. The second stage was caught by the chopsticks. The main ship drowned. And I think I should have put this as a 2 here. Let me go back to the other scene. And a 3 here. This is the set cursor location. and this one should be maybe 6 and 7. So there's some space between them. So there's 2 spaces in between actually. Okay, so that worked. All right, so let's continue on. Let's see what happens when I change. Well, let's go ahead and change the initial command from the C8 to C0. And this is, I'm assuming this is normal mode. And according to this, previously it said normal mode, I think. Table 10.3. So what is 10.3? Okay, here we go. This is interesting. So sequential COM pin configuration. So we have COM 0, which is row 0. COM 31 is row 31. COM 32 is row 32. And then COM 63 is row 63. So if we change this to C0, what do you think is going to happen in normal mode? I know there's a little bit of a lag. I think there's probably a like a 4-second lag in the video, so I'm not going to see your responses for a little bit. Okay, so let's go ahead and try it. You guys can state what you think if you want to. I'm going to go ahead and press play, and it should completely show something different. It should maybe do a different type of scan, or it will show the same thing. Okay, look at that. It is upside down. It is mirrored, I mean. So if you put it to C0, it starts at this corner here to the bottom left. So if we wanted this to show normal, we would have to change all of our character values. So we'd have to redo our characters. So all of these numbers would have to change if we did that. So let's there are other values we could change with the C0 and C8, but that would be, I think, over here. Set lower column start address and set higher column start address. So we could change these values, and I believe this relates to the COM output scan direction. Let's read a little bit more about that. All right. Okay. So what is it? This is just an address, and I think maybe this has to come right after this. Okay. So probably won't find that information, but let's see. Sequential COM pin configuration DAH A4 is equals 0. COM output scan direction from COM 0 to COM 63. So COM 0 here to COM 63. So this is the normal, and it's weird that it's normal because the yellow would be the top in a normal output, because the yellow is I was talking about this in the last video, the last live stream. Why is this yellow and why is this blue? But I saw some examples where this is sort of a status line here, or this area is a status area. Like if it was going to be used for a display on a device that had a battery, it would show battery consumption on the top or something like that. Okay, so the C8 is I'm guessing the row 0 is up here, and then row 63 is down here. Zishan, thank you for coming in. Welcome. What happens if this command is mapped to a button? Does it need the OLED to be no, it doesn't, because it said it will run immediately. So if you put a button and you wanted it to be flipped for this specific one, it will be flipped immediately. So if I made, we can actually test that. So let's go ahead and bring this into our while loop, and we can flip it. So let's flip it. Let's go ahead and use the C0 here, and then we'll have a delay in between. Sorry about that. All right. Okay, so we'll bring this to C8. Was it C8 or was it C? I can't remember actually. What does it say up here? Who remembers what that value was before? C8. Okay, good. So let's see. Do I have a delay? I do have a delay somewhere that I used. Looks like I'm not actually using. Yeah, I do. This is milliseconds. So I can do it for every second. I can flip it every second. So 1,000 or 100 milliseconds. 1,000 milliseconds would be 1 second. So let's see what happens when we do this. So I'm going to go ahead and press play. And it looks like it works pretty fast too, actually. It doesn't show a drawing of the display every single time. I'm wondering if it uses its own frame buffer to do this, because I do believe that you can opt to use a frame buffer, but I also have this going at 1 megahertz. So this I2C is actually in fast mode plus. So if it is not using the frame buffer, then you're looking at something that is actually forming very quickly, which is kind of cool. This would make a lot of sense if you had something that required the flipping of it, and it would make sense both directions. So that would be kind of an interesting thought experiment. What would that be? All right, so let's go ahead and we can go ahead and take this out because we know what this does, but we don't actually know what happens. Let me change my scene here. We don't actually know what happens if we change the scan values or the high and low values. So let's go ahead and try that. Let's see what happens when we change these values. So 1 0, what would that be in binary? So let's look that up. Anybody have any guesses what that would be in binary? I did a tutorial on how to convert from hex to binary in another video. It was pretty easy to understand, and I can't remember how to do it. So, all right, so this would be 0x10. Let's see what that would be. Okay, so that would just have a 1, 2, 3, 4 zeros and a 1 at the 5th location. So what if we put a 1 here? Let's swap. What would this convert to in hex? That would just be an 8. So let's see if what happened if we just put an 8 here as the higher column start address. Lars, thank you for coming in, and 16, I don't know what that means. Is that your guess for the binary number? Zihan, very nice, thank you. Yeah, you're welcome. All right, so let's change that to an 8 and see what happens. And this will, of course, we'll only get this information here. We won't get anything else. So it should show something, because I have it going all the way down. I should probably fill in that little space there. All right, it stopped because it's getting ready to flash the microcontroller. Okay, so nothing happened. So we didn't affect anything. So let's change the upper number. Actually, I want to put something in those missing lines first. Anybody have any suggestions on what I should put in before I put it in? Yeah, guess whatever you want to guess. That's awesome. All right, so what should I put here? I could put just a bunch of X's, or let's see. Okay, I'll put that in. All right, let's go ahead and run it. Okay, so we have a full, and the next probably went to the next line, but we can't see it because this one wrote over it. So let's take some of that out. I'll just put wait for next. All right, let's go ahead and run it. All right, great. Okay, so that 08 doesn't seem to make much of a difference to what is actually shown on screen. So what if I change it to, let's see, where's my other, there it is. Let's see what this is. That's 4, duh. All right, so 04. I wonder if it changes it somewhere else. Back to, no, I don't see anything else here. I could change the what is it? The lower column start address and see what that does too. Yeah, it doesn't seem to change. So do I even need these? Let's go 04 and a 10 here. Okay, nothing happens. So do I even need these? Let's go ahead and take these out and see what happens. I'm going to comment it out so I don't lose it. Nothing happens. So I guess we don't need these. If anybody else knows whether we need these or not, let me know. But maybe it could be because of the way we have this set up too. If I change this to C0, what would happen? Let's see. It should flip, should flip this direction. So, but if it doesn't and we get some kind of error on the screen, we'll see, or some nonsense on the screen, we'll know. So I'm running it now. Okay, so nothing happened. So these two lines don't actually mean, they may mean something, but they don't affect what we're doing. So I'm going to keep those out. Now this sets the display start line. So this probably has some effect on it. So what would that be? So let's take a look at the data sheet again. And this would be a value that probably, so what would happen if we change this? Let's see, let's put the, so that would be a 20. What would happen if a 20 goes here? So setting the display start line, will it shift it all down? Oh, look at that. Okay, so we are getting backs. So you can see at the very bottom, it's interesting, it started at the bottom though. So only the last line showed up. What would happen if we change that to a 0? So we're probably getting a continuation from the end and going back to the start, but it's getting messed up. Oh, look at that. If we have a 0, it's normal. All right, so what if we change that to a 10? Okay, so we might not even need this because this could be a default. Let's see what happens if we don't even use it. It was a 40 before, I think. I'll only show you this portion if it doesn't work, so I'll keep it at this scene. All right, so nothing happens. So we don't actually need it. It's probably set as a default, but I'm kind of curious what would happen if I go above the 40 number. So if I made it like FF, or not an FF, but 80, what would it be? 80. Okay, yeah. So what if I made it 80? What would happen? Nothing. So it only changed when I changed it to 20. Right. So that's interesting. So I'm going to keep this. I'm going to comment it out, but I'm going to keep it here because this is probably something that is a default, but we don't really need to set to send that command to the display. All right, so we have the contrast, and if anybody knows more about this, let me know. I'll probably do a little bit more reading later on this. Like set display start line. Actually, we can read it right now. Okay, so it's 40 to 7F. So let's take a look at what that is. All right, here we go. This command sets the display start line register, table 1, 10.1. Sets the start line register to determine start address of display, RAM, by selecting a value from 0 to 63 with value equal to 0. RAM row 0 is mapped to COM0. With value equal to 1, RAM row 1 is mapped to COM0, and so on. So table 10.1. Wouldn't that be back up here? Okay, here we go. All right, so column, these are columns. I don't think this is correct. For 10.1, that doesn't seem, I think it's talking about this here. So I think they got that wrong. Well, we can try a different value. So from 0 to 63. 0, we already know what happens. So 63, what is 63? What does that do? That is the maximum. Oh no, that wouldn't be 0 to 60. That would be 63. No, that's 7F I should do. What am I doing? Although that's interesting what it did. It actually, it set this, let's see if we can find out where the start is. Okay, the start is like right here. So it's kind of in the middle of the display. Hey Bleach, how's it going? Thank you for coming in. We are testing the different commands on the display and seeing what happens when we change the commands. So let's change this to 7F, which is the maximum. So what is 7F actually in I'm curious with this too. 7F. Okay, it's all ones. So you have the values from, it doesn't ever get to an FF because it is a 7-bit number rather than an 8-bit number for those values. So I guess what is 60? I guess it's 64, yeah. So 64 would be this number in decimal. Let's check. So decimal to binary, let's do that. 60, I guess 63. Yeah, well, no, that's 6. And then that's 7. So that's interesting. So there would be 60, I know there's 63 or 64 rows. 63, from 0 to 63 would be 64 rows. So if I started it at an odd number, maybe it'll start from the middle of the display. So let's see what happens with that. And now we're kind of seeing what would happen. So let's see what happens if I use something in between 40 and 7F. So let's go back to hexadecimal, or actually let's go from decimal to hexadecimal, so it's a little bit easier to understand. So let's go 30. Well, that would be somewhere in the middle of 64, so I want to go somewhere like completely arbitrary. Let's try 25, 19. All right, so where does it start? It started at this line here, so it's very similar. So it looks like it's starting at a particular row. So there's 63. This is 128 by 63. So it is, let's do this. I'm very curious. I think we're going to have a scrolling effect. Who knows what I'm going at here? Who knows what you think I'm going to do? Wait, I forgot how to use the for. Is it a parentheses? Yeah. Yeah. Okay, so while we'll use I equals 0. I'm not using I don't think, somewhere else. While I is less than, say, 64, let's increment I. And we're going to put this command inside of this for loop. And we're going to increment the value. But I think I need something before that first. I'm missing something here. There's a syntax error. Oh, I have to specify the type. All right. I still have a syntax error. Who knows what I have wrong with this for loop? I is equal to 0, semicolon. I is less than 64, semicolon. I. Oh, do I need a semicolon here? No. Okay, that's why. All right. There you go. Thank you. Thank you, STM32 world. And welcome. Let me answer Bleach's question. I know it's not the time for it, but yes, parallel port doesn't have the jog problem. But still, it was worse in terms of missteps overall. That's interesting. Linux CNC had 0 missteps with the same system. It's also free. Yeah, I encourage the use of Linux CNC. I encourage everybody to use that instead of Mach 3 or Mach 4 or it is just a cleaner system, and it works flawlessly, but you have to have a parallel port from what I understand. And if you don't need a parallel port and you can use another card or a controller, let me know, because I would love to know and recommend that. Trying to loop a start line so you find the distance. In this particular case, I'm going to see this is the this command by itself doesn't really, could be doing something very, very bad, but it's going to be the start position, start row position, but I need to preface it with another command. So I'm going to look for that, the one that was right before it, I think, up here. So I think it's going to do a scroll. So the command just before that was here. Set output scan direction. So let's see, I may need this just before that other command. So let's see what happens. Maybe I'll blow up the display. We'll never know. Oh, I didn't put a time delay in there either. Ugh, yeah, it didn't do anything. Let me put a time delay in there. And it's probably not going to do anything. Oh, wait, I didn't change I didn't put I in here. All right, let me put a time delay. I can't remember what I called it. My delay. I should just keep it in there and comment it out if I need it. Oh, not there. So we'll do it every tenth of a second. So let's see what happens. Do I need to change it to hexadecimal? I think it does that automatically. Nope, nothing happens. That's interesting. It just went blank. Let's get it back to the way it was. So that was a fail. So this is not the command to preface this start. Maybe I need to do a clear screen too before I do that. Yeah, I don't think I need to change it to hexadecimal. It should understand the value. As long as you're putting the value in, it should automatically know that that's an integer of some type, and it will do that automatically. You did see a rapid scroll. Maybe I can put a longer delay, and it's not working anymore. So that's an interesting thing. Let me see. Did it? Yeah, everything looks good. Uh-oh, I may have ruined it. Yep, I probably blew it up. All right. So if I blew it up, we're gonna have to go with a different topic. What I should do is actually power it down for a little bit. See, is it hot? No. Let's power it down for a little while. It should have the correct program on the microcontroller, so that shouldn't be a problem. Let's power it back up, reset it. Okay, we're back to normal. All right, so now we know not to do that, but let's see what else we can screw with. All right, so this, it does set the specific start line, but what would I need to use to preface this to make this work? So what maybe I need to do this first. Okay, let's try it with 1000 milliseconds. That's 1 second. Unless I have this 48 megahertz thing wrong and it's longer, but I doubt that. See, these little experiments is what excites me. I really enjoy doing this. Should I put the delay before or after? Let's try after still and put the 1000 there. I don't see any change. Unless it's working in 8 megahertz and the 1 second is actually 8 seconds. Or not 8 seconds, it would be 8 divided by 40, or 48 divided by 8. Did you see any change? I think I need to preface it with putting it inside of a mode. Oh, look at that. Look at that. What number was that? You know what? I should show the number on the screen. Wait, you know what? I'm not drawing anything. That's why. I'm not drawing anything while I'm doing this. So let's draw something. So let's go ahead and draw. We'll start from the set cursor at 0. So what we'll do is we'll actually show the value of I. Do I need to convert this to a string? I do, don't I? Who knows how to do a conversion of a string from an integer? I have the standard lib here, so I should have that command somewhere. Yeah, yeah, but I would have to put that into another variable, wouldn't I? I've used that before, I just don't know how to do it anymore, so let me just put some character, and then somebody can give it to me in the chat. Help me out. All right, so let's print the letter A. I'm going to reset, and hopefully it gives me enough time to do a, let's see, yeah, it worked. All right, good. But, oh yeah, because it hasn't gotten, I don't think that 1 second doesn't seem right. So I'm wondering if it's not really in 48 megahertz. Yeah, let's do 200. Yeah, I don't think I'm working in 48 megahertz. Okay, that was interesting. Did you see that? I think it was too fast for us to see. And I really don't think this is the right command to preface it. All right, so I'm gonna use because it really didn't matter if I use that command or not anyway. Like if I commented this out, I think that was a default anyway, or it was C0, I can't remember. But what we could do is we could set memory addressing mode first, so these two, and then do it, and see if that helps. But I'm questioning the what do you call it? My clock, my actual clock, to see if it's actually set correctly. Yeah, I'm doing that. I'm writing. Oh yeah, I'm writing a string A at set cursor 0, so that cursor's position should be moving if I change the row pixel location. So let's see. Jabari, how's it going? Thank you for coming in. I want your help to programming STM32 for building keyboard. I could get into that in a later live stream for sure. We can, when we get into like inputs and things like that, we can do that for sure. Otherwise, if you want help right now, I do have button press. I have the what is it? I have a matrix keyboard that I did, and I showed how that works, and you can look that up. But I also have the button press input and button to bouncing videos. All right, so write a loop. Put a car every iteration on the screen so you can determine your speed. Yeah, I think that's what I'm doing here. So let's go ahead and keep that 250. Let's put these two. Let's preface it with these. I think that will sort of initialize it and get this to work. Because the only thing above that is set display off. So I believe all of these may have stuff in common, or the start line here. So those three things may need to happen. These three things may need to happen first. I am not using CubeMX and HAL. I am using, well, in the beginning of this particular OLED live stream, which was 2 live streams ago, I used Claude to create this program. And this is the system clock configuration. And I generally do everything in register level. And I've done this specific clock configuration, 48 megahertz, in a previous video, doing it line by line using register level. I also did it using CubeMX in previous videos. This was probably maybe 2-3 years ago. So you can take a look at that, how I do that, but I didn't want to redo that. I wanted to, and it's doing it correctly according to what I see here, using the PLL, invoking that clock and setting it to 48 megahertz. If you see anything else that doesn't seem right, let me know, but that's how I'm doing it. So let's see what this does. First I need to make sure that, because I'm probably not going to be able to do a flash because of the problem that I ran into before. Let's see what happens. Yeah, so I need to reset the screen. Let's do it again. It's still set at 250 milliseconds, so let's see what happens. So I have an A character being put on cursor 00, and once it finally gets to that point, it should go there immediately though. That's weird. Did you notice that? Something going on here. So I don't understand this line well enough. So I guess this is, not this line, but this line. So I guess you can only do this when it's initialized. So I would need to maybe set the display off every single time and do a lot of other things here. Oh wait, set display start line. Oh no, that's not it. Set contrast level, set segment remap. Maybe I need to turn the display off first and then turn it on. So we have still a lot more commands to go through. So let's go ahead and continue on and address that one later. No pun intended. How much power does that display use? If it's less than 20 milliamp, just power it from a GPIO pin. Yeah, I was going to do that. I didn't want to use a MOSFET or a transistor to power the display because you'd have to do that. Yeah, if it's less than 20 milliamp, and I don't think it's going to be less than 20 milliamp. That's going to be pulling more than a pin can provide, I believe. But I was considering doing that in the beginning, for sure. Can you do an OLED clear in the for loop? Yeah, let's do that. And that will also tell us if let's do a clear and just setting. Let's start simpler. Let's keep this line, and I'll do a delay, and I'll do a clear, and I'll show maybe a B or something like that. So I'll clear it every time, and we'll at least be able to determine whether. Oh yeah, the clearing. We weren't clearing it, so we wouldn't be able to see the A anyway. So that's another thing. Let's do the clear. So we'll clear it first. We should show the delay after the clear. So we're clearing it, then no, wait, whoa. No, we need to do this. Yeah. So we're clearing it, we're showing something, we're showing it for 250 milliseconds, then we're going to clear it again, and then show the B for 250 milliseconds, and then it clears it again. So it just keeps doing that for 64 iterations. So let's try that. Yeah, okay, so Gorzd, and thank you for coming in, welcome. You could set the cursor to I times 5 plus 1, 0. So every iteration, your character will be one character width plus 1 pixel displaced. Interesting. Yeah, I could try that. I was thinking you were going to say it would go line by line, but if that could be a pixel, that is true because it would be. But does that cursor location? Is this a complete 5? Is this a 5 bits or 5 pixels, or is it a pixel by pixel? But I think it's character by character, I think. So I think it skips 5 pixels each time. We could look at the set cursor code to find that out, which we should eventually. So let's see what this does first. And we'll try that as well. Let me plug in the ST link. I will reset it. But STM World, I appreciate that comment because, yeah, if it does require less than 20 milliamp, you could use a pin because the pins are. Oh, check that out! It worked. Did you see that? It actually worked, and I didn't show it. I didn't notice it. You guys didn't notice it? It actually worked. Let me go back to. Well, let me do this one first, just to see what happens anyway, and then we'll go back. But it did work. And I believe it's because maybe I went too far. Maybe 64 is... Okay, this is working at 48 megahertz. So this is correct. Yeah, okay, cool. Bleach, yeah, thank you for that. Yeah, I should have cleared the screen. But still, it happened so fast. I wonder why. So let's Let's try it again, but using the clear screen. But this looks like it's 250 milliseconds every time. So I think we got the 48 megahertz correct. So let's go ahead and go here. Let's separate these two codes. Well, I don't really need this anyway. Well, I do need the A. Let's keep that clear. Let's just get rid of that one. And let's go ahead and... Okay. So what does everybody think is going to happen? Will it work? I think these values are wrong, personally. Because I think that's why it messes up at the end. And it only allows 64 iterations. But something happens even before that. Because like, if you're waiting 250 milliseconds each time, yeah. Let me just go ahead and stop talking and do it. I'm going to go back to the other screen here. Okay, I should show the, so where was that? I like the ATOI. Can somebody give me a line of using the ATOI? All right, it stopped. Did it show something different? Or did it show something surprising? Let's try it again. Okay, that's interesting. It went outside of the normal values. Okay, the ATOI accepts a string and makes it a number, it looks like. So sprintf maybe is what I want to use. Okay, character. I've put this in so many of my tutorials, but I can't remember when I'm doing it. Okay, so we could use this. Yeah, Gorst, that is that is more code that I would like to use. I could use sprintf. Let's use that. Of course, it's not going to tell me how to do it this way. Or C. Let me use C. Okay, here we go. All right, so I'm going to be making a buffer. Okay, so the value, and then it's going to be decimal. It won't be 20 characters for sure. So let's do something like this. Let's use the sprint. All right, so we have to initialize a variable here. So this would be a car. We probably only need maybe, well, let's do 10. I mean, we have 10 lines. I mean, 10 character spaces at least. And the value would be I. So we're going to be printing out the buffer. We're not going to be doing, yeah, we should be able to do this, yeah. So this is, I guess, decimal, right? We probably don't need that, but let's go ahead and try this. Okay, I could also use printf. Yeah, okay, so yeah, you're right, STM32 world. I could have, you pretty much put the whole thing in there. char buff 10. Okay, yeah, there we go. Oh, it's an integer? Okay, good. Thank you, Adams. I appreciate that. And welcome. All right, so let's go. This should work then, right? Let's go ahead and run it. See what happens. I saw some errors there. Although I still have showing A. 7 warnings. Oh, this is from my other programs. All right, so what is this telling me? It's not, I'm not casting it, but it's casted here. Oh, okay, all right. The A, so I'm not doing this right. Look, what am I doing? It shouldn't be buffer here. Control Z. Okay. I'm getting all turned around here. Let me go back to here. And the buffer should be here. Still. Okay, here we go. We got it right. All right, so now we can see the actual number. Yeah, no, looks like I don't need the address. Okay, you see that? 42, it caused something. 45. Okay, so 40 is the maximum. I thought that was 40 hex, but 32 did something too, didn't it? It's not going to work. I think I need to reset it. Oh, no, it's going to work. Look at that. All right. Still not working, though. Let me reset this. So it got to, let's see what it does at 32. Okay, so that's something special. So at 32, the address kind of, I guess, is and it doesn't, let me go to 39, because it doesn't start over. And I'm still getting some error here. Let's see. From incompatible pointer type. So car buffer, car isn't the right type for the buffer. That's interesting. All right, it's not working at all now. There we go. I could probably go a little faster. You can see it's drawing it every time. Okay, so if you hit 40, or if you hit, excuse me, if you hit 40, it messes up. And it looks like it's messed up again. Where did it mess up? All right, let's see. Passing one argument of sprintf from incompatible pointer type. And it doesn't give me any more information. Excuse me. No. This should work, but I think the issue is over here. You think that it needs to have a cast here? Yeah, I'll do that. It makes sense. Let's see what happens with that. So we're forcing a cast on this, on the buffer. Yeah, it's still Even when we cast it, it doesn't do that. It doesn't work. But it'll still probably work in the program, which is kind of odd, isn't it? It still works, but there's a warning. It's not fatal, so that's not really a big deal. All right, but so something is happening at 32, and it does start over again, but then it messes it at 12. It stops working. I'm not really sure I understand that, but could have something to do with how the rows work, because you can see that there's COM 0 to COM 31, but then it has COM 32, there's one right after it, to COM 63, which relates to the row 0 to row 63. Let's see what happens when I try, I believe it was, I can't remember who said it. Let's see. Well, somebody stated that we could change the set cursor. I want to play with that and see what happens. I'm curious if the cursor is going to react in the same way. So I'm going to take these out. We don't need these anymore. So if I just put like I here, then it's just going to go character to character, I believe. And we can check that out just to see what happens when I put I here. This is the X value going left and right, and this is the Y going up and down. Okay, so I didn't need to pass the address. It's a use without pointer. Yep, I could do that. Oh, to use the car without the pointer or the buffer without the address. I can try that and see what happens. Let me see if this works. Yeah, still doesn't. But it'll probably still work anyway. I gotta reset. Let's do it again. Okay, I'm not clearing the screen. Am I? No, I am. Oh, look, it went away. So that worked. So we have no more errors. Yep, nothing. But this is not working anymore. So this was working before. It was working before when we did this, actually. So we can just do this portion here. Let's try that. Oh, it's still, look at that. Yeah, it still has that same. So maybe I didn't get it. Didn't. Hey, Adams, no problem. Skeptic, how's it going? I don't think I welcomed you in. Yeah, buffer. So you think I need to actually show the number of characters as a parameter input, or the array space? Yeah, no, we're printing the value of I. What we were doing, Adams, was we were we were experimenting with this command here, which is the next command I'm looking at. The command was, first we looked at this and we understood what this does, and then we're looking at the set display start line. So there are 64 lines here, and this value sets that start line. And the value, I believe, was between 0 and 63 according to this data sheet. So we were just playing with that, seeing what happens if I change this in a loop to see if we get the starting position going down from top to bottom. So I'm going to put all this back in here and see, because we had it working for a second there, and this still seems to be an issue. And it does clear the screen because we had these put back in, but it's not showing anything. So I'm going to go ahead and take this back out. Put the address back in here. It was working with that address. Yeah, somebody in the chat told me to put the 10 in just to see if I can get rid of this warning. Warnings kind of bugged me, but it's not really important in this case. So this is what we have right now. So all it does is it counts up with the I, but it doesn't really do anything with setting the location, the row location. So there's some prerequisite we need to make this work. And this is what I was trying to figure out, but it's not that important because it's not really necessary to understand it at this point. But it's a fun little experiment to see what happens if I did change that. So I think I want to move on to the next thing, unless you want to keep trying to see if this works. Or we can also do that set cursor increment to see what happens with that, which I'm kind of curious to see what happens. And I'll take this out. I don't really need this anymore. And I thought I didn't need any of this either, just the clear. But apparently it didn't work unless I did have that. Yeah, I did that, and it showed the same thing. Let's try it again. That was how I started with the Sprint F. All right, I'm probably going to have to reset it again. Yeah. Okay, so it still works without the address, putting the address, the thingamajig on the before the buffer. Oh, look at that. Did you see that? It is increasing by a single bit, but it's doing that for, yeah, so it's increasing by a single bit. So let me see if I shouldn't need this, obviously, and I shouldn't need this as well. So I could, what if I went all the way across, but I multiplied, just like somebody else said in the chat, I could use the set cursor, but if I go, how far can I take this? Because it would be this would be an integer. Could I take this all the way to the very end? Yeah, I could do the character width. That would do one character, but we're looking at individual pixels going down. But I mean, yeah, we could do that. We could do that as a way to see how far it goes. Because if it goes all the way to the end, that means that the number can be high enough to accept. Because 128 times 64 is a very large number, and I don't think we can fit that into the byte size. So I'm thinking it's going to be we can only do it the maximum of what word length is. Yeah, I'm going to be changing the Y too. But this is actually by line. This is not actually by pixel. This is by line. So let's see what happens when I do by 8. Well, this is actually, it should be by 5, because an 8 is more than a character width. 5 is the character width, which is 5 what do you call it? So it does go to it. Yeah, it goes to the next line. So if I multiply this by 60, would it go to the next line? But it's going to be, this number is going to be too big to fit in that word length. Obviously, it's probably just going to error out with the display, and it'll just go to a value that, yeah, 5 plus 1 space. Yeah, it could be 1 space. I think it's 1 space, so it's probably 6. You're right. But again, this is just an experiment to see how we could get this to start or to work inside of a for loop. But let's go ahead and move on to the next thing, because I don't think we're going to be able to get anything going with this specifically. We can look at movements and things like that later on, because I believe there are commands that allow it to do vertical scroll and things like that. So let's go on and move ahead. All right, I'm going to get rid of all this. Actually, I'm just going to get rid of all of this here. And let's take a look at the contrast and see how that works and what the values would need to be for the contrast. I'm going to bring this back to 40, which was the initial value. Let's go ahead and see if it still works. I got to plug it back in. And also, we noticed when we did make a change here, we were able to make it go down a certain number of lines, which unintuitively, in the for loop, it didn't work. So it's very odd that worked the way it did. All right, I need to reset it. I'm getting some errors here. What the heck? I like when errors happen live stream. I have no idea what that was, though. All right, so, okay, Peter, how's it going? 5 plus 1 space. Yep, that's going to be I think I read that already. All right, so let's take a look at the next thing. This is the contrast. So setting the contrast control this is the getting ready to set the value. So this is the contrast value. So tell the display I'm going to change the contrast. This is 81. Can it accept any other values? Let's see. So is there something other than a contrast value? Yeah, it's the first one. Look at that. Okay, so there isn't any other value that it could be, because these are all set in stone essentially. So 81, and then the value would be the next thing. This is a reset. So reset is 7F. So it's actually a reset value. So let's see if what would happen to the contrast. This is not brightness, I'm guessing. This is I don't know what it's going to do when it does the contrast, but I'm thinking it's going to be more of a brightness setting. At least that's what it does on like a what do you call it? An LCD display. You'll start to see everything become very. If you have it too high, then you'll see blocks everywhere. So 7F, what is that value? We can go somewhere in between, I guess. Let's go from hexadecimal to binary. So that would be ones all the way across. So I could do maybe just 4 ones. That should be somewhere in the middle. or probably a little bit higher. That's just F, 0F. So let's change this to 0F. See what happens. It didn't look like it changed it that much, but it did change a little bit, I think. We can also use this in a loop to see what would happen. We don't need this one anymore, or maybe we do. I don't know. I kind of let's keep those. Let's keep this going and using this value changing for the contrast. Let's go back to 40 here. Our maximum value is 7F. What is that in decimal? That's 127. So we can go from 0 to 127. All right, so we're printing out the buffer, the conversion from I. Well, let's take this out. Set cursor should be 0. We don't need to actually write anything to the screen. We can just keep this stuff up and just show. First of all, we can keep this in here. We'll keep the display, the delay in here. Maybe make it a little faster, like a lot faster actually. 10 milliseconds. We don't want to clear it. So all we're doing is we're changing the contrast, and we want to see if we can change this on the fly too. Thank you, Peter. 127. I should just rely on you guys to tell me the answers. So we're setting the contrast where contrast value will be I, and let's see what happens. It's going to be hard to see on the camera because looking at it without the camera, you don't see that waviness in the timing, I guess, for the camera shutter. So you'll have to trust me if it works. Let's see what happens. And if you don't see it on camera, you'll have to trust me. I definitely see a change, but it doesn't look like it's happening every... Oh wait, no, it's happening so fast that... Let me make it a little bit slower. Let's go 50 milliseconds. But I don't think it goes that dim. It's pretty... I can't see it with my eyes, actually. Let's see. Oh yeah, I can. Yeah, it doesn't go very dim, does it? Let's go even slower. Let's go 100 milliseconds. Yeah, thanks, Wally. I appreciate that. And welcome. Yeah, it doesn't get very dim, does it? I mean, the contrast delta is extremely small, so that's the dimmest it can go. So let's just make it 0 and see what that looks like, and then we can delay 1 second, and then we can show it as 100. Just see what happens. It'll do this 127 times. So you should see it go back and forth. Dim, bright, dim, bright, dim, bright. And that didn't work at all. I don't need the set cursor actually. It's showing something. I can see it with my eyes, but I can't see it on the camera. But it's showing, it's like flashing something on the screen. So I think, is there another clear in here? No. Oh, you know what? I need a delay after it too. I'm wondering if I don't think my phone thinks that I have a, oh, look at that. 0 is off. So you know what? It makes it 1 before it, yeah, it increments it before it shows 0. Let's just show 1. So there's a clear screen for you. Okay. See, that is the maximum contrast. That's the dim, that's the bright. Dim, bright. So now we understand the contrast. It doesn't really contrast that much. It's very, very low. It's like sleeping mode, bright sunlight mode. Sleeping mode, bright sunlight mode. All right, let's go and look at the next thing. I'll keep that stuff in there. Setting the contrast control, we did set segment remap. This is an interesting, see what that does, A1. Okay, so this is a set segment remap. What does A0 do and what does A1 do? This command changes the remapping between the display data column address and the segment driver. It allows flexibility in the OLED module design. Please refer to table 9-1. This command only affects subsequent data input. Okay, so it won't change the whole display on the fly. It'll only change as you're inputting data or as it's receiving data. So when you change it, it'll change it to only the data that comes next. Data already stored in the GDD RAM, which is essentially the display, will have no changes. When they refer to GDD RAM, they're talking about the display because the display is a bunch of addresses, I'm thinking. All right, so what's 9-1? I should have just clicked that link. Figure 8.7, there is no 9-. Wait, oh, it's in this command table. So A0 and A1 are the two values we can use. We can see what happens between the A0 and A1. And if we even need to use a set segment, what is the so the A0 is set column address 0 is mapped to segment 0 reset. the A1 is set column address 127 is mapped to segment 0. So let's see what happens when I change it to A0. All right, so we shouldn't have anything in the while loop. We're just going to be showing this stuff here. This is not necessary, and this isn't necessary anymore. Let's go ahead and play. I need to show this more often, I think. So you can see more of my code. So all I did was I changed, if you didn't see that code, I apologize, but I just changed the, oh, look at that. From the A1 to A0, let's do that again. So it should set 0 to segment 0. Okay, now it shows it, oh, this is interesting. It shows it in the other direction now. So when we changed the COM port output scan direction from C8 to C0, it flipped it in this direction, like with the y-axis. But when we change the segment remap to A0, it flips it in the horizontal direction. So that's interesting. Let me see what happens when it should be now a reverse of both. If I put C0, let's put C8 here so I remember the default value. So if I change it, if I flip it with the horizontal and I flip it with the vertical, let's see what happens. We should just get a rotation, a complete rotation. All right, now we can actually see it because we flipped both both horizontal and vertical by using the scan direction for the, changing the scan direction and changing the set segment remap, which these command descriptions are very obfuscatious. They're very confusing. So it would be difficult to understand what it's really saying, but it needs to say that because of, for engineers and design, they could be starting in a completely different location, somewhere in the RAM or the display RAM, and need to see it in that way. So this is essentially flipping in the horizontal. I'm going to actually put that in here. I'm not really sure if that's a good way to even say it. Or I should say mirrors vertical and mirrors horizontal. And we could actually redefine all of our characters to read it the correct way from the top to the bottom, but we'd have to change everything to do that. So this is an interesting way to flip. So let's continue on. Go back to A1. I'll put A0 here just so we know the other value. Okay, set normal display. What does normal mean? Let's see, A6. So normal display is reset. Did we already look at this? No. So normal display reset mode, I guess. 0 in RAM, off in display panel. 1 in RAM, on in display panel. So the other way we could put this in is A7, which inverses the display. So we just essentially inverted the display. Let's see what that does. So A7, wait, no, this one right here. Let's see, A6 is the default. Let's put A7 here and see what happens. All right, it is 3:18. I'm probably going to be signing off because I'm 18 minutes overdue. Oh, look at that! It inverted the pixel on or off. Inverse display pixel wise. Yeah, okay. Not the direction or anything, but that inverted the pixels. And it really doesn't show well on camera, but it's perfect in real life. It is the vividness is incredible. Like the blue is so blue and the yellow is so yellow. It's just unfortunate you can't see that in. It looks more like this, but it's even bluer than this. Page 28 of command table. This is 28. Yeah, thank you. Yeah, this is where it's located. That's what I was reading before. All right. So I am probably going to sign off at this point. I appreciate everybody watching. I actually wasn't intending to come in today and do a live stream since it's Columbus Day in America, but I want to continue doing this daily so it becomes habitual. It becomes a normal routine for me to do this every day and come in. So tomorrow we'll be talking about CNC stuff. I want to continue with the shielding. Hold on one second. I'm going to turn it on to my beautiful face if it works. Let's see, Canon full screen. There we go. So tomorrow I'll be intending to continue the experiments with shielding. But I know Bleach has some questions regarding the motor, so we were doing some motor experiments, which I'm very fond of. I love doing experiments, especially when it comes to what the chat wants to do and wants to see. I am going to be publicizing my Tuesday and Thursday on my website, just so more people know that I'm doing this, so they can see or ask questions. I do have a customer service live section of my website. I don't monitor it that much. I should, but the live stream is a good way for customers or enthusiasts or hobbyists or whatever that want to ask me questions or show experiments. I don't know everything, and obviously, but I learned through these experiments, and I'd love to see what you guys want to see in terms of experiments. If I don't have the item in stock to show the experiment, consider sending me what you have. If you're stuck with something, send it to my address. I have that on my website, and if I don't, you can just email me at phooddaniel@berkeley.edu. Let me put that in the chat so you guys know. And you can email me at that address and let me know what you want me to do before the live stream, obviously. And if you want me to look at something that you have, I have no problem experimenting with equipment that you might have that you wanna bring over if you're not using it, or if it's not going to hold you up in any way, because I won't be able to tell you how fast I'll be able to get to it. And just understand that when I send it back to you, it'll incur a shipping charge on you, not me. So with that, thank you all for coming. I'm very excited for tomorrow and doing some experiments and having some fun with maybe blowing up a motor or something. That'll never happen. But hope to see you there, and thank you for coming in.